This video covers notes 4.4 over domain and range. In notes 4.3, we did domain and range, and we looked at all of the x's and all of the y's. Remember that domain is all of your set of first coordinates, all of the x's, and our x-axis goes side to side. So the range is all of our second coordinates, so that would be all of the y's, and our y's go up and down. So when we're looking at these graphs today, the only difference between yesterday and today is that the graphs look a little different. They're not as pretty, but we're still going to do the exact same thing. So with the x's, I'm looking side to side. I write it up at the top just so I'm not scribbling all over my graph. But if I start at the 0, I go to the left 1, 2, 3, 4, and that gets me to -4. At -4, I have run out of line. There is no more line anywhere to the left of -4. So -4 is going to be one endpoint of my domain. If you look at -4, there is a filled in bubble, so we put a less than or equal to. Remember, if you have two endpoints or two confirmed stopping points, you put X in the middle along with another less than sign, and then you go figure out where else it goes. So to the right, my X values go 1, 2, 3, 4, 5, and at 5, they run out of values. At 5, I have a closed bubble, so I put a line under the inequality. Now, when I'm looking at the range, I'm looking bottom to top. Remember, we always go left to right and then bottom to top. We always go least to greatest. So as I'm working my way down, I'm looking at 0 and I go down 1, 2, and at -2, there are no more values for this function. There's no more line and there's no more dots. So I put a -2. And then I go to the top, I go up 1, 2, 3, and at 3 is where my values stop. Remember, I'm always going least to greatest, so I should have the smaller number and the bigger number this way. It doesn't matter which order you find them as long as you go least to greatest. So if you had them opposite on your assignment yesterday, make sure you go bottom to top or least to greatest. So this one looks like what we did yesterday. Our domain, our x values, we start in the middle, we go to -1, and we run out of values. I just do a plain inequality because there is no filled in bubble. And then I go to the right, 1, 2, 3, and at 3, I've run out of values. So bottom or left to right. And then range, we're going to go bottom to top. So my y's, I go down 1, 2, 3, 4, 5. So I have values all the way to -5. Range covers my y's. And then I go up 1, 2, 3. And at 3, I've run out of values. So this one, still doing the same thing. My domain, I go to the left, 1, 2, 3, 4, 5. At -5, I have run out of values. And then I go to the right, 1, 2, 3, 4. At 4, there is a filled in bubble, but at -5, there was not. So notice the differences in my inequality signs there. For the range, I go down 1, 2, 3. At -3, there is an open bubble. And then I go up 1, 2, 3, 4, and at 4, there is a filled in bubble. Now this one gets a little different, okay? So just hang with me. We are still doing the exact same thing, okay? I start at 0, and I have values all the way to the left until about -0.5. Now notice I'm not using my endpoint. I'm using the leftmost value, which is -0.5. That's what we've been doing on all of the rest of these. We just have had endpoints where our leftmost and rightmost values are. So this one, I go all the way to the left until I run out of line or dots. It's you keep going until you've run out of the function. So then I go to the right, 1, 2, 3, 4. And at 4, there's an open bubble. Now notice, if you have part of your line, it's going to be the line under the inequality because there is a value here on this line. My y values, I'm going to go down 1, 2, 3, 4. So I go to -4. There's an open bubble. And then I go up to 1, also an open bubble. So when I look at this problem, my domain, my x's, as I go to the left, 1, 2, 3, 4, 5, and if you notice that arrow means it's going to keep going. I go to the right, 1, 2, 3, 4, 5, and that arrow means it's going to keep going. So if I have arrows in both directions, if it goes all the way to the left, that's negative infinity. And then if it goes all the way to the right, negative infinity. Notice there are no lines under the inequality because we cannot say for sure what infinity is. We know it's a really, really, really big number. We know it's a really far place away, but there's no definite number there. My range, as I go down, I stop here at -2, but notice this arrow means it's going to keep going down. And then here, I could stop at -4, but this arrow means it's going to keep going up. So this is also negative infinity to positive infinity because it goes down for forever and up for forever. So this problem looks very similar. We have arrows, meaning it's going to go forever to the left and forever to the right. So negative to positive. And then my range, arrows are going up and arrows are going down. So it's going to go down for forever and up for forever. So remember, if you have arrows, meaning it's going to continue in those directions, it goes on for forever. So negative infinity to positive infinity.